The sun is the most essential element of our solar system. It's the source of all light and life on Earth. But could this life-giving force actually turn against us? What if one day, the sun's magnetic field flipped or collapsed, triggering a series of catastrophic solar storms that send our world into chaos? This is not just a theoretical scenario, but a real concern for scientists monitoring the sun's unpredictable behavior. If a solar storm similar to the Carrington Event of 1859 were to occur today, the consequences could be catastrophic for our highly technological society. The once unimaginable possibility of a massive solar storm affecting everything from power grids to communication systems is now a very real risk that has experts worried. It's easy to take the sun for granted. Every day, we rely on it for warmth, energy, and light. It's a constant presence in our lives, predictable in its rhythms and reliable in its warmth. But beneath this apparent stability, the sun is anything but calm. The sun is a massive, complex ball of gas, mostly hydrogen and helium, constantly undergoing nuclear fusion at its core. This fusion process releases vast amounts of energy, which powers the sun and creates the solar wind, a stream of charged particles that emanates from the sun's surface and extends far beyond the orbit of Pluto. The sun's magnetic field is equally complex, generated by the convection of hot plasma within the sun. And just like the sun's surface is constantly in motion, so too is its magnetic field, undergoing fluctuations and reversals every 11 years or so. These cycles, although regular, are not predictable in the exact intensity of their storms, and that is where the danger lies. What would a solar storm actually do? At first glance, the phenomenon might sound harmless. After all, we experience the auroras, the beautiful northern and southern lights, that are caused by solar winds colliding with Earth's magnetosphere. However, these are just the benign effects of solar winds in small amounts. The real danger comes from large, violent solar storms, like coronal mass ejections, CMEs. A CME is a massive burst of solar wind and magnetic fields rising from the solar corona and then being released into space. If a CME is directed at Earth, it can cause a geomagnetic storm that disturbs Earth's magnetosphere. Under normal conditions, the Earth's magnetic field acts as a shield, deflecting most of the harmful solar radiation and high-energy particles. However, when the sun emits a particularly strong burst of solar wind, like during a solar storm, it can overwhelm this magnetic shield. The effects of such a storm on our modern world could be devastating. Our electrical infrastructure is vulnerable, and a powerful solar storm could knock out power grids, causing massive blackouts across entire regions. The telecommunications systems that we depend on for everything from news to emergency services would be disrupted. Satellites, which we rely on for GPS, weather forecasting, and communication, would be at risk of being damaged by intense radiation. Airplanes, which depend on satellites for navigation, could lose communication with ground control, potentially leading to crashes. Hospitals, banks, supermarkets, and other essential services that depend on electricity could be knocked out for weeks, if not months. The social consequences would be equally severe, as a breakdown in communication, transportation, and power would likely lead to widespread panic and social unrest. To understand the risks, we need to look back at a historical event that gives us a glimpse of what a major solar storm can do. The Carrington Event of 1859 was the most powerful solar storm ever recorded. Named after the British astronomer Richard Carrington, who was the first to observe and document it, the event was caused by a massive solar flare followed by a coronal mass ejection. The particles from this storm collided with Earth's magnetosphere, producing brilliant auroras visible as far south as the Caribbean. But the real effects were felt on the fledgling electrical systems of the time. Telegraph lines across the world went down, and some telegraph operators were even shocked by the electrical surges. Sparks flew from telegraph machines, and fires were started in telegraph offices. Despite the technological limitations of the time, the Carrington Event showed the world how vulnerable electrical systems were to solar activity. Fast forward to the present day, and the situation is far more concerning. Our society has grown increasingly reliant on technology. Electricity powers nearly every aspect of modern life, from our homes and businesses to our communication systems and healthcare facilities. What was once a minor disruption in 1859 would now be catastrophic. If a storm of similar magnitude were to strike Earth today, the effects could be even worse. The global power grid could be severely damaged, potentially taking years to fully recover. Satellites in orbit, essential for GPS navigation, weather forecasting, and communication, could be destroyed or malfunction due to the intense radiation. With satellite communication knocked out, airlines might struggle to keep aircraft in the sky. And that's just the beginning. The disruptions could cascade, affecting everything from banking systems to food supply chains. There are further risks too. A massive solar storm could unleash a powerful burst of radiation that could damage human health. High-altitude flights, such as those over the polar regions, could expose passengers and crew to dangerous levels of radiation. Astronauts in space could also be at risk, and a CME large enough to interfere with Earth's magnetic field could put the lives of astronauts aboard the International Space Station in immediate danger. For those of us on the ground, the risk from radiation is significantly lower, but it's not zero. The high-energy particles from the sun could impact communication systems and power grids, but they would also have the potential to harm satellites in space and even disrupt the functioning of electrical appliances. The unpredictability of solar storms only adds to the worry. While scientists have long studied the sun's cycles, they've come to realize that it's far more unpredictable than originally thought. The sun operates on an 11-year solar cycle, during which its activity increases and decreases. This cycle is marked by the appearance of sunspots, regions of intense magnetic activity on the sun's surface. When the sun is nearing the peak of its solar cycle, the number of sunspots increases, and the likelihood of solar flares and coronal mass ejections rises. The current solar cycle is expected to peak around 2025, but scientists are already noting strange behavior that is unsettling. In the early months of 2024, an unusual sunspot appeared that produced a series of intense solar storms, visible as far south as the United States, Europe, and even Australia. While power outages were mostly confined to specific regions, the storms caused such disruptions that even Elon Musk's Starlink satellites, which are meant to provide global internet coverage, experienced issues. If this is just the beginning of what's to come, the worst could still lie ahead. Scientists were once confident in their ability to predict solar activity with accuracy. They used historical data, computer models, and telescopes to observe the sun's behavior and predict when storms might occur. But recent events have shown that solar activity is more complex and unpredictable than they had realized. For example, in 2003, a solar flare exploded and sent a powerful CME toward Earth. The flare was detected only minutes before it arrived. In that case, the particle stream from the sun took just 20 minutes to reach Earth. Larger ejections can take up to 2 days, but the unpredictability of these events means that the planet can sometimes be caught off guard. It's not just the solar flares and CMEs that we need to worry about, the sun's magnetic field itself is changing. Scientists have observed unusual fluctuations, and some are concerned that we may be in for a massive disruption. A sudden and dramatic shift in the sun's magnetic field could trigger an even more intense solar storm. As scientists continue to monitor the sun, they remain cautious but optimistic. They believe that the sun's behavior will continue to follow a general pattern, and that solar observatories will provide enough warning for us to take precautions before a major storm hits. However, there's always the chance that a surprise event could occur, and the scientists aren't willing to rule out the possibility of a storm even more severe than the Carrington Event. It's a reminder that, for all our advances in understanding the universe, we are still at the mercy of the forces of nature. Could we survive such an event? In a worst-case scenario, the Earth itself would be fine. The planet's core and atmosphere would shield us from the worst of the radiation. But the infrastructure that sustains modern life, our power grids, satellites, and communication systems, would be vulnerable. A solar storm large enough to disrupt these systems would leave society scrambling to restore order. In such a scenario, there would be no quick fix. It could take months or even years to repair the damage, and the social, economic, and political consequences could be far-reaching. While some solar storms are relatively benign and cause little more than a few beautiful auroras, the potential for a catastrophic event is always present. And as we've seen, even the sun's most predictable behavior can still surprise us when we least expect it. In conclusion, the sun, which has long been a symbol of stability and warmth, holds a hidden potential for chaos and destruction. The solar storms that it occasionally produces have the power to disrupt our modern world in ways we can't fully predict. As we continue to advance technologically, we also become more vulnerable to these natural events. Scientists are doing their best to monitor the sun's behavior and prepare for the possibility of a massive storm. But as the events of recent years show, the sun is not as predictable as we once thought. The question is no longer if a major solar storm will hit us, but when. Are we ready? Only time will tell.